Function-oriented software design, we have talked about this in previous chapters or sessions. In this, we'll see about larger example of structured analysis. We have already seen examples of structured analysis and also structured design. The major objective is that you should be able to develop structured design from any DFD model. We have prepared DFD model, and now I'm trying to tell you how you can make a structured design using a DFD model, which is actually our architecture. So we'll take examples and summaries also. So we'll have one more example, that is trading house automation system, TAS. So a large trading house wants us to develop a software for them just to automate bookkeeping activities associated with its business. And it has many regular customers who place orders for various kinds of commodities. So the trading house maintains the name and the addresses of its regular customers. And each customer is assigned some unique ID, that is customer identification number, CIN here. And what is the current practice, that when a customer places the order, the accounts department will check the credit worthiness of the customer. And if this credit worthiness of a customer is determined by analyzing the history of his payments to the bills which is sent to him in the past, and if the customer is not credit worthy, his orders are not processed any further, and appropriate order rejection method or message is generated for this particular customer. If the customer is creditworthy, item he or she has ordered are checked against the list of the items the trading house deals with, and the items that the trading house does not deal with is not processed any further again, and the message which is appropriate to the customer for these items is generated. The item in a customer's order that the trading house deals with for the availability in the inventory, and if the items are available in the inventory in desired quantity, a bill with forwarding address of the customer is then printed, and a material issue slip is also generated. The customer can also produce the material issue slip at the storehouse. It can take the delivery of the items and inventory data which is adjusted to reflect the sale of the customer. And if the ordered item is not available in the inventory in sufficient quantity, then in order to fulfill pending orders, stores details in a pending order file, which is out of stock items along with the quantity which is being ordered, and then CIN, that is customer identification number. So the purchase department, what it does, would periodically issue commands to generate the indents, and when these indents are generated, the generate indents command is issued to for the system should examine the pending order file and then determine the orders that are pending, the total quantity required for each of the items. This TAS should find out the addresses of the vendors who supply the required items to them and examine the file containing vendor details. Of course, the address, item they supply, and they also print out indent to those vendors. And TS should also answer managerial queries like what are the statistics of different items sold over a given period of time and the corresponding quantity sold and the price realized. So this is context diagram of what we have talked, level 0 DFD. Manager, customer, purchase department. This is the trading house automation system. Manager query, he gets the statistics. Customer order, he gets the response. Purchase department, it generates the indent, and that the indent is given to the external entity. Let us make a level 1 DFD. Okay, we will start from here and how we can decompose the functions. You can very well see here that this is 0.1, 0.2, 0.3 and 0.4. Accepting the order from customer history, customer file, item order and inventory. Then handling this processing order from all these. Handling indent request from vendor list, indent request, pending order. And handling query also with respect to query statistics and also from sales statistics. That is the process order 0.2 will take inventory and take accept order and then pending order. If it is okay, handle indent request, also produce material issue slip and bill. So this is the example data dictionary of what the problem we have just discussed. This is the complete data dictionary for it. And what are the observations here from the examples? We observe that DFDs would help to create the data model as well as the function model. As DFD, we have refined into level of details. The analyst perform an implicit function decomposition or exploding. And in the same time, refinements of data also takes place. So there are certain guidelines for constructing DFDs. This context diagram should represent the system as a single bubble. And we have already seen that in many cases. And many beginners commit the mistake of drawing more than one bubble in the context diagram. It shouldn't be there, only one bubble will suffice. All external entities should be represented in the context diagram. You cannot leave, ignore, avoid, or oversight these external entities in your context diagram. So external entities should not appear at any other level of DFD. This is very important. Only at the level 0 DFD. 3 to 7 bubbles as per diagram should be allowed, and each bubble should be decomposed between, say, 3 to 7 bubbles only. A common mistake committed by many beginners is just to attempting to represent control information in the DFD. For example, trying to represent the order in which the different executions are executed. This is not what you show in DFD. Another guideline for constructing DFD is DFD does not represent control information, as we have seen that some beginners would want to do it. When or in what order different processes or functions are invoked or they take place is not to be disclosed here. So the conditions under which different functions are invoked, they are also not presented. Just for instance, a function might invoke one function or another depending on same condition. But many beginners try to represent this aspect by drawing one or an arrow between the corresponding bubbles. Let us take an example. Check the input value. If the input value is less than this or greater than this, generate an error message, otherwise search for the number. This is a context diagram, but you have three bubbles. This is not acceptable. You don't have any number here, and this is not a good idea. So if bubble A invokes either bubble C or B depending on some conditions, then we will represent the data that flows from bubble A to bubble B and then bubble A to C, but not the conditions depending on which a process is invoked, not the conditions at all. Let's take one more example. A function accepts the book name to be searched for the user, and if the entered book is not a valid book name, we generate an error message. But if the book name is valid, we search for the book name in the database. This is get book name, then we print error message. Good book name, search book. This is not required here. So, all function of the system must be captured in the DFD model. You cannot skip any function, and no function specified in the SRS document should be overlooked. It has to be in SRS. Don't overlook them at all. Only those functions specified in RS document should be represented, and do not assume extra functionality of the system not specified by the SRS document. These are the commonly made errors. First of all, unbalanced DFDs. Forgetting to mention the name of the data flows, it has to be there, and unrepresented functions of data. Also, external entities appearing in level 0 context diagram, high level DFDs. Trying to represent control aspect which is not even required. Context diagram having more than one bubble, only one bubble is allowed. And the bubble decomposed into too many bubbles in the next level, more than 7. Or terminating decomposition too early. That means less than 3. And nouns used in naming the bubbles. Bubbles are only composed of functions which only verb can represent, only verb. So what are the shortcomings of the DFD model? The DFD model suffers from several shortcomings. DFDs leave ample scope to be imprecise. In a DFD model, we infer about the function performed by a bubble from its label, and a label may not capture all the functionality of a label or bubble. Just for example, a bubble named find book position has only intuitive meaning. What does it mean? It does not specify a few things. What are these? What happens when some input information is missing or incorrect? It does not even present or convey anything regarding to what happens when the book is not found, or what is going to happen if there are books by different authors with the same book title. So control information is also not present, or you cannot represent in DFD. For example, order in which inputs are consumed and outputs are produced, they are also not specified, so it becomes very difficult to understand sometimes. How can you understand if you are not given any proper control information in this particular case? So DFD does not specify synchronization aspects also. For instance, the DFD in TAS example we discussed at long stretch in the beginning of this discussion does not specify whether process order may wait until the accept order produces data, whether this accept order and handle order may proceed simultaneously with some buffering mechanism existing between them. TAS, this is level 1 DFD, and you can very well see we have already showed it to you that all those things which I told you, you can very well find out what are the shortcomings. So the way decomposition is carried out to arrive the successive level of DFD is quite subjective, right? No quantitative or set formula. So ultimate level to which the decomposition is carried out again is subjective. This is analyst's choice, his own judgment. And even for the same problem, several alternative DFD may be represented there. There are possibility. And many a times it is not possible to say which DFD representation is good or bad. So DFD technique does not provide any clear guidance as to how exactly one should go about decomposing a function, and one has to use some subjective or intuitive or some past experience, experimental idea to carry out decomposition. And structural analysis technique, they do not specify when to stop the decomposition process, to what length decomposition need to be carried out. And if we want to extend DFD technique to real systems, for real systems, the system having clear-cut time bounds on their actions, we need to have an essential, or to make it essential to model control flow and events. This is a widely accepted technique. We call it as Ward and Meller technique. The type of processes that handles only control flows, they are only introduced, and these processes are represented using dashed circles. So this is the first part, and we're going to take more discussion into the later session. Thank you so much. Take care of yourself.